for having me. My name is Yahya Aseri from Kingdom of Saudi Arabia. I work at King Khalid University, and I'm so glad to join you in this conference. My presentation is going to be about modern standard Arabic and Saudi dialect identification. This work was done by my team at the Center of AI at KKU. And the task is to try to develop a system that can identify Saudi dialect, especially in Twitter, text it, so we can build in the future lexical resources and grammatical knowledge that help in understanding this variety of Arabic. As you may know, so much work has been done on Arabic NLP. But the major challenge is that Arabic has two levels of variations. One is called Modern Standard Arabic, which is the language of education, newspaper, formal language, documentation. And the other one is called Dialectal Arabic, which refers to spoken language in daily life and communication. From a natural language perspective, there are 5 major groups of dialects in Arab region. One is called Egyptian, Gulf, Iraqi, Levantine, and Maghrebi Arabic. These variations differ from one another in terms of lexical, morphological, and sometimes syntactic structure, even though they have the common grammar, even though they have common grammar. Another problem is that within each group, we have different variation, like Gulf Arabic, we have Bahraini, Kuwaiti, Omani, Qatari, Saudi, UAE, and Yemeni. The problem is when we use NLP tools developed for modern standard Arabic, usually fails in understanding or dealing with these text or this spoken language. Our question is how to start building a corpus for Saudi dialect that can be used for future application, NLP application, AI application. The first step is to start by developing a system that can identify Saudi variation from and distinguish it from modern standard Arabic. So this is the task, and related work. So many work has been done in Arabic variation and classification, identification. And there are 2 machine learning models that have been used. One, a multi-way classification, where the classes range from 3 until 29 classes, and sometimes it is based on the cities or countries or something like this, and not a linguistics label. The other one is binary classification, where the one class is the modern standard Arabic and the other class is a certain dialect of Arabic. The model used traditional machine learning algorithms and deep learning models. And here, no work has been done on modern standard Arabic binary classification between Arabic, modern standard Arabic and Saudi dialect, especially in the level of sentence. The task here is to classify or develop a system that can identify Saudi dialect extracted from Twitter. And our methodology as follow. We started by defining what we mean by Saudi dialect, because there is overlap between a spoken language in Saudi Arabia and modern standard Arabic in terms of the lexicon, grammatical morphology, and so on. So we define it as any text that contains at least one token that lexically or morphologically belong to the dictionary of Saudi dialect. And this is a broad definition, but the point here is to help us to start extracting these text. Then we extracted the data from Twitter, and we perform text pre-processing. Then we build dictionaries for MSA and Saudi dialect. Then we did automatic annotation. And we trained the model. We used 3 classifiers models. And finally, we test the model and evaluate it. First step in experiment setup is the text preprocessing. As any task dealing with such thing, we had to start with removing images, videos, hashtags, and cleaning the data, eliminating Arab diacritics because it may cause problem in classification. Also, we removed the stop words, even though we didn't remove all the stop words, because some stop words, it is distinctive features for such task. Then we deleted duplicate documents extracted from Twitter, like retweeted and such thing. The next step was building the dictionary. And how did we build the dictionary? We started with very short lists of vocab for modern standard Arabic and the Saudi dialect. These 2 lists were revised and approved by linguists who are experts in both MSA and Saudi dialect. We used these 2 short lists to extract text or sentences from Twitter and group them based on these short lists into 2 groups of documents. To expand the vocabulary list or the dictionary, we extracted all words from all text in each document set and added them to the corresponding list, which create 2 dictionaries. We removed the overlap section by eliminating the intersection between the 2 dictionaries, because as you know, in Saudi dialect text, they may contain words that belongs to modern standard Arabic dictionary. After we eliminated these overlap, we came up with 2 dictionary, one for MSA, which contain roughly 42,000 token, and 51,000 token for Saudi dialect. We used these 2 dictionary to refilter the two classes of the document though that we initially is extracted from Twitter. The the output are two classes that overlap because informal text or the dialect they may contain MSA words, as I said before. Uh, we eliminated the overlap, then we came up with a corpus that contained two data sets. One represent MSA, about 107,000 sentences for MSA and 128,000 for Saudi dialect. These two data sets were combined and shuffled to make sure they are normally distributed, and we wanted to avoid the overfitting. Uh, After having these two classes of documents, we start training our model by converting them to vector representation, and our features was in gram features, namely one and by unigram and bigram. Then we used the three classifiers that can fit for this task: naive-based classifier and logistic regression and support vector machine. The result, as you see, we didn't split the data to training data and test data. We used tenfold to train our model and test our model, and we see, as we see, the accuracy of these algorithms almost the same, and we achieved high accuracy using twofold training and evaluation. We want to evaluate our model on another data set that has been labeled by human to compare the performance of the model that was automatically labeled and the human label. And as you say, the data set was about 15,000 tweets from Twitter, and it were labeled by Saudi students who are experts in Saudi dialect and modern standard Arabic. And as you see, the accuracy of the model, the best accuracy was by naive base, achieved about 89 accuracy and 88 F score. The drop in this result may be attributed to some dialect or some sentences may contain phrases that belong to Saudi dialect, and these phrases are about two modern standard words can combine with each other to be a Saudi dialect phrase. This can be recognized by human, but with the machine, cannot be recognized. Also, the name entity, we dealt with name entity as a token. In the future, maybe we need to use the name entity recognition before we do such task. I think other orthographical issue uh, was another factor in dropping this result. So in the future, uh, the conclusion, we achieved good result in this task. And as you see, naive Bayes is the best classifier for such task. This result also considered as a baseline for future work. And in the future, we may improve our model by using additional feature sets like um, uh, trigrams or something like this. Also, we may consider a normalization of the text before we did the classification and use another name entity recognition tools before we did something like this. And this is a short presentation about our paper and our work in AI Center at King Khalid University. And as I said in the beginning, I was glad to join in this conference. Thank you.